Okay, please do scan your attendance before we start our session today. Okay, everyone, how are you? Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon.
Waalaikumsalam.
Okay, so today we're going to learn the deflector. So, anyone know what is a deflector?
Doctor,
Yes.
can you show the QR code again?
Okay.
Okay, thank you, Doctor.
Okay. So, everyone, have you ever heard or do you know about deflector? What is deflector? What does a deflector involve in the fluid mechanic? What does the deflector involve in the fluid mechanic? So basically, the definitions of deflector is that it is something that deflect the moving fluids. Alright, we have the moving fluid from one position to the another. It will deflect, right, from position A, and it will deflect to position B. That is what we call a deflector. It deflects the fluid, the motion of fluid. So you can see here, this is the turbine. Anyone knows what's the functions of turbine? What's the function of turbine? What's the function of turbine? Okay, based on energy equation. Energy equation said what? Okay, based on the energy equation, which is P1 over gamma plus V1 squared over 2G plus Z1 plus the work rate of pump over mg equal to P2 over gamma plus V2 squared over 2G plus Z2 plus what the last thing? Work of the turbine
MG.
over mg. And another more? Plus
Loss.
heat loss. Okay, the heat loss is K V squared over 2G. What is K? K is the elbow loss coefficient. We call it as a loss coefficient, yeah? Maybe from elbow, from the contraction. Okay, there is a loss. So we call as a K. This is maybe K2. This is maybe K1. So to find the K, which is K1 plus K2. Alright. So this is the turbine. Why the turbine at the point number 2? Okay, based on the energy equation, why the turbine at the point number 2? Point number 1 is the
Input. Bernoulli.
Yes, input. Siapa cakap tadi tu? Betul tu. Input. Output. is point number 2. So input, we input the energy. Output, we extract the energy. That is why turbine located at the point number 2, which is at the output. Turbine output the energy. Output the energy means give the energy, extract the energy from the fluid. So this is the fluid going through here. Okay, this is, you can see the turbine. Alright. So this is the nozzle. And the nozzle hitting this bucket. The bucket will rotate, okay, anti-clockwise direction. The rotations of this bucket will induce the electrical energy due to the movement of the shaft. Okay, so where's the deflector? The deflector is located after the nozzle. You can see, maybe they want to adjust the position, they want to adjust the angle of attack. That is why we place they place the fixed deflector. The fixed deflector means it is stationary, it is permanently there, it is not moving. Okay, all right. So based on this turbine, and then we put the deflector, the momentum equation is often associated with the deflector in analysis of turbo machinery like turbine, pump, and compressor. There are two deflectors in fluid mechanics that you're going to learn: the fixed deflector and the moving deflector. Okay, so for this case, there are two categories. Deflector, the stationary and the moving. The stationary means the deflector like this is fixed. Okay, fixed deflector. This is water. The moving deflector means this deflector from one position will move to another position. Okay, so far you guys understand the concepts of deflector? Okay, we have the assumption when we deal with this deflector. The first one, the pressure external to the fluid is constant. And second one, negligible of resistance. Okay. Number 3, a lateral spreading of plane jet is negligible. That means we are not consider any z-axis into the page or out of page, the motion. The body force and the weight of control volume is small, negligible. So as you can see, this is the conceptual view of stationary deflector. All right. So what can you deduce from this picture? Okay, this is the nozzle. The nozzle, okay, this is the water inlet from this position until point number 2. So this is B1, and upon outlet, the direction changed already, which is to B2 with the angle alpha. The angle here depends on the deflector angle. So who's the holding the deflector from moving? We have the reaction force. The reaction force hold the deflector from moving. That is why we call it as a reaction. That need to counter back the momentum coming from the nozzle outlet. Okay. This is assume no lateral spreading. So that means there is no spreading in the Z direction. It is only X and Y direction, 2D. Okay. So you can see this is Y and this is X. There is no Z. There is no motion in the Z. We assume, this is our assumption. Alright. Okay, from the Bernoulli equation. Do you remember the Bernoulli equation? Okay. I believe you remember the Bernoulli equation, which is V1 over gamma plus Abdallah
Z1.
over G plus Z1 equal to V2 over gamma plus yes plus C2. This is the incompressible. That is the change of density is less than 3%. Okay, from this Bernoulli equation to apply to this stationary deflector, since this is the area here, and the cross-sectional area here is the same. So Q1, we know that Q1 equal to Q2. This is the continuity equation. Since the area the same, okay, Q1 equal to Q2, Q equal to A multiplied with velocity. Alright. So area is the same. So we can cancel out area. We found out that velocity at inlet equal to outlet. Okay. And next, the pressure is constant external to the fluid jet. Okay. So, when we deal with the steady and uniform flow, do you still remember what is the uniform flow? The velocity profile constant. This is uniform flow. Okay, this is what we call a uniform flow. The velocity is constant. Alright, so it is steady. Steady means d over dt of the system equal to 0. Alright, this is based on the Renault transport theorem, RDT. Okay, we know that based on transport theorem that we derived previously, I believe you remember, yeah, d mv over dt equal to d over dt. This is control volume, alright, rho v dv plus this is control surface, rho v v dot n dA. Okay, so since this is the steady state, the first term we can cancel out. Okay, and this term basically is the mass multiplied with acceleration. You can see mass, velocity with time is acceleration. This is the force. Okay, this is the summation of force. So equal to integrations of control surface rho v v dot n. This is unit product dA. Okay, so from here we can finalize that the summation of force in the momentum equation is equal to, okay, control surface rho v v dot product, yeah, dA. Okay, this is quite simple. So let's say we can apply this momentum equation to this case, which is we have one inlet and one outlet. So this is at position 1, one inlet, and this is at position 2, outlet. Right. So from here, from this equation, we can apply control surface at point 1 to point 2. So this is, let's say we can put point 1 to point 2, inlet to outlet. So we will have F equal to rho v v2, okay, v2 and A2 minus rho V1, V1 and A1. Apply the momentum equation. We know that M, mass flow rate, is equal to rho A V. Okay. So from here, you can see we have rho, we have V, and we have A. Okay, so we can apply here the summation of force is equal to mass flow rate multiply with V2 minus mass flow rate equal to V1. Mass flow rate the same, okay, because we have the same volume flow rate. So finally, M is equal to V2 minus V1. Okay, so where's the V2? This is V2. Where's the V1? This is V1. Okay, what do you think of this? This is one-dimensional or two-dimensional? You can see here. 2, 3 or 2, 1. What's the number of dimensional? We have x-axis and
two-dimensional.
yes, y-axis. This is two-dimensional. So we need to divide this equation into two-dimensional. Okay, so from here we can say Fx summation of force in x component is equal to mass flow rate V2x minus V1x. Okay, you can see here, I just put the x component. Okay, when we deal, okay, so what's the force in the x component? You see here. What's the force involved in the x component? What do we have? We only have the reaction force. Okay, the reaction force in the negative x direction. So what do you think? Negative Rx or positive Rx for the summation of force? It is the R, the reaction force. It is pointing to the left. So pointing to the left, it is negative. Okay, mass flow rate is the same, yeah. Okay, V2. How to get V2x? Okay, this is V2. This is V2x. And this is V2y. How to get V2x?
V2 cos alpha.
Yes, perfect. V2 cos alpha minus V1. V1 is only one component, right? V1x. So this V1x is equal to V1. Okay, we know that V2 is equal to V1. Can I factorize V2? This is equal to V1. So I know already M. This is replace V1, yeah? Okay. Finally, cos alpha minus 1. That's it. Okay. Anyone? Do you have any questions so far pertaining to the force in the horizontal component? Okay, now let's do for the y component. Summation of force in y component is M V2y minus V1y. Okay, what's the force in the y component involved? Only the reaction force pointing upward. So Ry is positive or negative?
Positive.
Positive. Mass flow rate. Okay, how to get V2y? V2 sin alpha. Okay. In order to get V2y, V2 sin alpha. Okay, so just put it here. V2 sin alpha minus V1y. What's the value of V1y?
0.
Okay, perfect. Absolutely 0. Do we have velocity in the y component? Uptick upward? No, we only have one component, so it is definitely equal to 0. Minus 0. So we know already V1 equal to V2. So we can replace V2 with V1. So finally, the mass flow rate equal to V, okay, V1 sin alpha. That is the reaction force for Y component. So this is totally the momentum equation for two-dimensional applying to the stationary deflector. Okay, that's it. So far, do you have any question pertaining to this equation? Have you done your lab experiment for this deflector? Anyone? Have you done the lab one?
Yes, sir.
Okay, I'm pretty sure if you have done the lab one, you will deal with this momentum equation at deflector. I think the Pelton will. Okay, so you will involve with this equation. So I think that's all for today. But before we end, I have the assignment for you. But this assignment quite different from previous assignment because this is the programming assignment. Okay. So how to get the programming assignment? Okay, first log into e-learning. Okay, why you need to do the programming assignment? Because this is part your coursework. Okay, when you go to your course information, you see here. Okay, assignment contribute 10%. Programming assignment contribute 10%. Test 1, 20%. Test 2, 20%. And your final 40%. So this programming assignment finally will contribute 10% of your mark. Can you see the total allocation only 4 hours? But I give you time to do it within 1 week. Okay, instead of 4 hours, it's very tight. So you open your course section and then you will find that the programming assignment fall under this week 9. Okay. In this programming assignment, this is the programming assignment where you need to complete within 1 week. Okay. So this assignment contribute 10% of your mark. Okay. In order to enhance your mark, okay, I put the bonus part in which you need to provide your testimonial of the lecturer and fill up in the given form. Okay. This is just a bonus. All the files should be zipped in one folder. Okay, for the testimonial form, separate in one document and upload it here before the deadline. Okay, the first assignment, you look at here. Okay, this is during a semester break, yeah. Next week is a semester break. Okay, this is your programming assignment. Anyone, can you see this assignment?
Yes, sir.
Yes, doctor.
Okay, as a graduate engineer, you are asked by your employer to develop the programming solver to help them calculate the fluid mechanic parameter for various situations such as Bernoulli Equation conservation of mass, momentum, energy, and etc. You are free to use any programming language such as MATLAB, C++, C, or Python. So I would advise you to use the MATLAB, okay, to create a program that cover any topic in the fluid mechanics. An example of programming has been developed using this code for you to understand. Okay, please make sure use your own programming code to show your program functionality to help the company solve the problem. Okay, for example, the company would like you to have the Bernoulli Equation calculator. Okay, this is the programming. This is just sample, yeah. I took from the internet. Okay, this is how you attach your answer script. You do the coding, and then attach a screenshot your coding into this document like this, and finally print out the working program. For example, please choose either equation of mass, momentum, or energy. Type number only. So I type number 2. I choose momentum. So you will get the reaction force. Please enter the mass flow rate. I enter 5. Enter initial velocity. I enter V1 equal to 2. Enter the final velocity, which is 5. Thus the reaction force is 15. Thank you. So process exited after 10.3 seconds. So this is how it works lah. Okay. Do you have any question pertaining to the programming assignment? So far you guys understand? I assume you understand, yeah?
Yes.
Yes, doctor.
So how to score? Okay, based on this rubric score. Okay, how do I evaluate your programming skill? It is based on interactive program. Okay, contribute 20%. If you want to score outstanding, conduct a series of questions like I did previously. A series of questions, that is a simple question. Conduct a series of questions by asking the raw data such as pressure, diameter, and etc. So readability, contribute 50%. Provide all the comment for the brief explanation, the important subject in line. Okay, for example, when you do the coding, okay, let me show you. When you do the coding, okay, for example, please do all the comment here so that I understand. Please choose either equation. This is the comment. You mention clearly the comment box. The question 1, this is for question 2, this is for answer. Okay, please provide all the comment for and briefly explain the important subject in the line. Organization and clarity, your coding, proper function and condition, smooth flow and clean and neatly. Okay, this is the most important. Contribute 45, major of the mark. Complexity. I want to look at the complex of your codes, implement the complex formula in the fluid mechanics, and advanced structures such as nested loop, if-else statement, and etc. Okay, time submitted. Okay, if you submit within time, you got 2 mark. Okay, this is the bonus part. This testimonial. This is the extra part. Okay, you can see all this 100 plus 5. For example, this one you score 10. Maybe you score 8. This is you score 9. This is you score 30. And then you get 70. So how to increase more? You can put the bonus mark. So this is the bonus. Simple sentence and explanation 0 to 1. Complex sentence and explanation 2 to 3. And complex and honesty explanation of lecturer 4 to 5. Okay. So how to do that? Okay, you go to this one, testimonial form. Okay, can you see? Your picture, your name must be capital, your metric number, capital, your phone number, and finally your claim. Example, this is the structure. You can do on your own. Okay, if you don't have any idea, you can use my template, my format. Your claim, this is example, this is outcome of the result, and hoping. That's it. Okay, so this is the testimonial form, sample one. I give to you. Macam ni, like this. This is your picture. This is your name, everything your detail. Capital letter ya, di sini. This is your claim. Example. Because of this is the outcome. And then I hope that continue. Okay, that's it. It depends on you. This is just an extra. If you want to do that, it's okay. If you don't want to do, it's never mind. Okay. Okay, I think that's all for today. Do you have any question pertaining to the programming assignments?
And Doctor, can you show the QR code?
Okay. So for the programming assignment, due date on Monday, 17th of May. Okay, I give you 2 weeks basically. Around 2 weeks to complete, almost 2 weeks to complete the programming assignment. Okay, so the rule, please do not copy and paste your friend work. Okay.
Doctor, do we have to make a report? No.
The report, just put it here. Okay. You make the programming kan, and then pergi di sini, go to here. Okay. This is the question. Okay, and then please screenshot your coding. All the coding, I think is a lot lah. And then lastly, your working program. And please also include your working program dalam zip file. This is the screenshot, the real working program. That means I click and then I can answer directly.
All right, Doctor.
Okay, this is the date lah. After this assignment is available for you. Okay, because I put it here as the hidden. Okay. So okay, you can see show week. Okay. So it is now available lah for you to do. Okay, anyone have any question before we end the session?
Doctor,
Yes.
for the bonus marks, what should we write in the testimonial? Like
Okay.
an example or something.
I think this is the format.
About
I
the
want you.
assignment itself, or
Pardon?
about the programming assignment itself, or something else?
About me lah, about your lecturer.
Oh,
This is
okay,
the
Doctor.
testimonial.
Okay, Doctor. Thank you.
Okay. You can see the example. Okay, the example I give to you, the example in the testimonial form. Okay. This is the
Excuse me,
testimonial.
Doctor.
Okay. Yes.
Do we have to use C++ code, or can we use MATLAB?
Yes, you can use MATLAB. It's advisable. It is better.
Yeah. All right. Thank you, Doctor.
Okay, welcome. Okay, anyone? I think that's all for today. Thank you very much for your time. It is 34 participants only. I know it is a lot. Okay, not coming. I think that's all. Thank you very much for your time. And selamat menjalani ibadah puasa. I end my session
with Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Salam.
Thank you, Dr.
Salam.
Selamat Hari Raya.
Selamat Hari Raya tu.